Good morning, good afternoon, good evening, wherever you might be, and welcome to another of my physics posts. This is called Blue Skies. In classrooms, we learn that the sky is blue because blue is a short wavelength and air molecules scatter short wavelengths of light better than long wavelengths. Violet has a shorter wavelength than blue, but our eyes aren't very sensitive to violet light, and that's why we see blue. Blue light is less polarized than the other colors because it scatters more times, and multiple scatterings destroy polarization. This is a convincing explanation, but it's not easy to understand unless you know what all of those buzzwords mean. But before I accept the conventional wisdom about anything, I always like to rule out some alternatives and try to say the same things in other languages, even if it sounds silly. What if the sky is blue because charged particles from the solar wind collide with air molecules? Both photons and electrons can collide with air molecules and make blue light. In fact, the northern lights are produced by the charged particles that leak around to the dark side of the planet. So, I'm not sure that this possibility has been ruled out. In fact, it seems entirely possible to me that this could be happening in parallel to the standard explanation involving Rayleigh scattering. When one considers the similarities between light and charged particles, maybe the distinction isn't all that important, unless you're trying to do solar spectroscopy, perhaps. In my blog post accompanying this video, I have some pictures of beams of charged particles that glow blue when in contact with air, demonstrating this mechanism. Another possibility I've wondered about is, what if the sky is blue because Cherenkov light is emitted when charged particles from the solar wind travel faster than the average speed of light in the atmosphere? If the atmosphere is treated as a continuous medium instead of as a collection of discrete scattering centers, perhaps this could be an equally valid explanation. Gravity bends light, so it has an index of refraction relative to gravity-free space. And in this context, the solar wind doesn't have to be moving at a ridiculous speed to emit blue Cherenkov light when the gravitational field of our planet slows it down. Going one step further, when the charged particle's trajectory is bent by the Earth's magnetic field, it is more appropriate to call the resulting radiation synchrotron light rather than Cherenkov light. And in my post, I have a nice picture of Cherenkov light from nuclear radiation interacting with water, and a picture of synchrotron light from a particle beam bent by a magnet. From my experience as an accelerator physicist, I know that two forms of radiation result from the deceleration of a charged particle. Cherenkov radiation from charged particles traveling faster than light in water, and synchrotron radiation from charged particles' trajectory bending in a magnet. Perhaps this concept can be inverted to give us yet another explanation. What if we imagine the molecules in our atmosphere moving relative to a gravity-free reference frame? They create a sort of optical grating which polarizes and filters the light, from the sun as it travels through the etheric blue electromagnetic wakes trailing behind the molecules. Backing up again a bit, we have 4 independent explanations for one thing. The sky is blue because shorter wavelengths scatter off of molecules in the atmosphere, charged particles scatter off of molecules in the atmosphere, Cherenkov radiation and synchrotron radiation, and air molecules that trace out etheric wakes which filter out solar light. Only one of these explanations is well supported by the scientific literature, but since it is possible for multiple independent explanations to be true at the same time, we often choose our favorite explanation based on simplicity and predictive power, qualities that depend on perspective. But if no single theory can simultaneously describe the part and the whole, one must always be of 2 minds to understand anything. So, which 2 of the 4 would you choose? I honestly don't really care that much which is the right answer. I'd rather go back to writing my novels. So I will leave you with that question to ponder. Why is the sky blue? Is there only one reason? Are there multiple reasons? How could we distinguish those reasons? And how can we tell when we are speaking in 2 equivalent, yet seemingly contradictory languages? Until next time, thank you for watching.